Let us study ionic compounds. What are ionic compounds? Ionic compounds are compounds which are formed by joining positively as well as negatively charged ions. Positively charged as well as negatively charged ions are oppositely charged ions. As a result of joining of or binding of oppositely charged ions, ionic compound is forming. Now, how ionic compound is forming? Because in between oppositely charged ions, that is positively as well as negatively charged ions, there is an attractive force. That attractive force is known as electrostatic force. Electrostatic force. So now we can define electrostatic force in other way. Electrostatic force is an attractive force, or we can say repulsive force. Attractive force between oppositely charged ions, repulsive force between similarly charged ions. But here in case of ionic compound formation, there only attractive force between oppositely charged ions. So the attractive force between oppositely charged ions, that is known as ionic bond. Ionic bond. As a result of this attractive force or electrostatic force, that electrostatic force, what is forming? Ionic compound forming. We can say that the force between oppositely charged ions, we can say as that is ionic bond. We studied in the previous classes, atom is electrically neutral. Atom is electrically neutral. Already we had studied. Why atom is electrically neutral? Because inside the atom there is equal number of protons as well as electrons are present. Because of that, atom is electrically neutral. Now we are studying that in an ionic compound, there is equal number of positively charged ions as well as negatively charged ions. Because of that, we can say that even ionic compound is electrically neutral. Ionic compound, its speciality, they are electrically neutral. Why they are electrically neutral? Because they are having equal number of positively charged ions as well as negatively charged ions. Now, with the help of examples, these two matter I will clear. Now, I am showing you an example of one atom, that is sodium atom. Na means sodium atom. Now, sodium atom, its atomic number is 11, mass number 23. Then electronic configuration 2, 8, 1. Now, protons number 11, electrons number 11. Even its atomic number is 11. So, we can say that in an atom, equal number of protons are having positive charge, electrons are having negative charge. So, in an atom, equal number of positively charged as well as negatively charged particles are present. So, we can say that an atom is electrically neutral. Now, what is about ionic compound? Ionic compound, for that one example I am writing here, sodium chloride. What is the speciality of sodium chloride? In this sodium chloride compound, here sodium atom as well as chlorine atom. According to you, now I am clearing you. Here I am saying you Na plus as well as Cl minus ions. We can say that joining of sodium atom as well as chlorine atom. As a result of it, sodium chloride ion is forming, or sodium chloride ionic compound is forming. In that, sodium ion will be there, chloride ion will be there. So just for an example I am showing you, this is sodium atom and one chlorine atom, single I am showing you now. As a result of it, here I am saying you 281 electronic configuration, here 287 electronic configuration. Now what will happen as and when this sodium atom as well as chlorine atom come close by? Sodium atom gives away its outermost electron to the chlorine. As a result of it, in sodium ion 2,8 electronic configuration will be. In case of chloride ion 2,8,8 electronic configuration will be there. So we can say that here this sodium ion loses one electron. At the same time here sodium atom loses one electron. As a result of it, sodium ion formed. This chlorine atom gained or accepted one electron from sodium. As a result of it, so a chloride ion formed. Now Na plus, we will call it as sodium ion. Cl minus, we will call it as chloride ion. Now this sodium atom and chlorine atom, when it comes close by, or when they come close by, they join with each other. As a result of it, sodium chloride compound is forming. We can say that sodium chloride compound is an example of ionic compound. Why it is ionic compound? In an ionic compound, there will be one metallic ion and one non-metallic ion will be there. Metallic ion we can call as cation. Metallic ion we are calling as cation. Non-metallic ion we can call as anion. So here sodium is a metallic ion, so we can call it as cation. Then chloride, that means it is came from, or it is formed from chlorine. Chlorine is a non-metal, so we can say that chloride ion is an example of anion. So negatively charged ions are known as anions. Positively charged ions we can call as cations. So here now, ionic compound is electrically neutral. Why it is electrically neutral? Because it has equal number of positive as well as negative charges are there. Here one positive charge, same time one negative charge is there. Second thing we can say that their magnitude of their charge. Magnitude of their charge, its meaning their strength. Positive charge has how much strength is there? How much magnitude is there? Equal magnitude is there to the negatively charged ions also. As a result of it, we can say that ionic compound is electrically neutral. So, why ionic compound is electrically neutral? Because it has equal number of oppositely charged ions. One reason. Second reason, both of them are having equal magnitude. Equal strength is there. As a result of it, we can say that ionic compound is electrically neutral. Now, one more speciality they are having. They are having crystalline nature. Ionic compound has crystalline nature. What is meant by crystalline nature? Crystalline nature, its meaning, ionic compound have a definite shape. They are having definite shape, second feature we can say they are smooth, third character we can say they are having shining ability. So we can say that ionic compounds speciality, they are having definite shape, they are having shining property, as well as they are very smooth. Now crystalline, its meaning what is there? A regular arrangement or periodic arrangement, or we can say that systematic arrangement of molecules. Now here we can say crystalline. Its meaning what? The first thing we can say that is having regular arrangement. Or we can say systematic arrangement. Or we can say periodic arrangement. Now, of what? Of molecules of ionic compounds, or we can say atoms of elements, we can say. Here now, in case of ionic compound, their molecules, their arrangement having a definite pattern is there. Now, if we are considering in case of diamond, diamond is an example of element. We can say that which element is a diamond? Diamond is the carbon element. Carbon element. So we can say that the arrangement of atoms present in the diamond, that is also having a fixed as well as a definite pattern of arrangement is there. So we can say that diamond is an example of crystal. Similarly, all ionic compounds, their molecules arranged in a regular pattern or regular arrangement they are having, or a systematic arrangement is there. One example I will show you now. Here now I made 5 molecules of an ionic compound. Here now both the side, here 5, here again 5 plus additional 2. Next arrangement will be there again 5 only will be there. All will be close to each other because they are in solid form. Now next will be there again a very proper, very systematic arrangement will be there. We can say that very careful arrangement. Again we can say that now same way 5. Next will be there again 6 will be there. 6 not 7. Both the side 1 will add. So we can say that a definite pattern of arrangement of molecules of ionic compound will be there. Then we can say that because of that we are calling as ionic compounds are having crystalline structure. So which all molecules are there, with the help of which molecules it is formed. That arrangement is in a very systematic way. So because of that we can say that the molecules of ionic compounds arranged in a very systematic way, very proper way or very regular way. So we are calling them as they are having crystalline structure. And In case of diamond, the diamond is formed with the help of atoms. Similarly, their arrangement also having a definite pattern. This is one example I told you. But I am saying you, all ionic compounds molecules are not arranged in the same way. The arrangement of molecules in different ionic compounds or in the crystals of different ionic compounds will be different. As a result of it, now I am saying you, suppose this is the example of one particular ionic compound. This is one ionic compound. Now other ionic compound will be there. The arrangement of molecules won't be in the same way. So we can say that here in our home table salt is there, or we can say sodium chloride is there. Normally we call it as salt. That salt is an example of ionic compound. That is an example of crystal. So we can say that crystalline table salt or crystalline sodium chloride. Similarly, we can say that crystalline sodium chloride, one example. Then other salts also we can say, that is potassium chloride. Again we can say sodium nitrate. These all are the examples of, again we can say crystalline structure of diamond. Like that way different salts are available. Now we can say that ionic compounds speciality, they are having metals as well as non-metals. Both of them are ions, sodium ion as well as potassium ion. We can say that cations as well as anions. In case of sodium chloride, sodium ion as well as potassium chloride ion is there. In case of potassium chloride, potassium is a metal, chlorine is a non-metal. Both of them joined together, potassium chloride is forming. One is a positively charged ion, other one is negatively charged ion. So in case of crystals, the arrangement of molecules of their compounds won't be in the same way. Here one model I shown you. Now different, there will be different models, different types of arrangement of molecules will be there. As a result of it, they look different. They behave different. So here I can say that in case of one ionic compounds arrangement I shown you this way. Now one more speciality is there. If we consider sodium chloride. Sodium chloride if we are considering. Now sodium, as I told you, its electronic configuration is sodium ion. Its electronic configuration 2,8. Chloride, its electronic configuration is 2,8,8. Now the arrangement of sodium ion as well as chloride ion in the crystalline form, how it is there I will show you. Here now sodium ion, because here you can see electrons number now 1 less is there. In case of sodium atom 281 is there. Sodium atom electronic configuration is 281. From that one electron already lost. As a result of it, here now electrons number less became. As a result of it, the size of the sodium became little less. Why? Because electrons number reduced. As a result of it, attractive force from the nucleus of the sodium increased. We can say that now this is the nucleus of sodium. So I am writing here neutrons number 11, protons number 11. At the same time here first orbit, it has 2 electrons. Second orbit, now only 8 electrons. This is sodium ionization. Now in case of sodium atom will be there. Here neutrons number 11, neutrons number 12. Here again neutrons number 12, protons number 11. Now First orbit has 2 electrons, second orbit has 8 electrons, third orbit has 1 electron. So this is sodium atom. Na, that is sodium atom. So here you can see that here 3 orbits are there, but here only 2 orbits are there. As a result of it, here from the nucleus towards the last orbit, less distance is there. At the same time, from here towards the last orbit, more distance is there. This is one thing. Second reason, number of electrons here more is there, but here number of electrons less is there. Because of these two reasons, we can say the pull from the nucleus is more. As a result of it, size of the sodium ion in comparison with the sodium atom is becoming less. So here we can say that in case of sodium ion, its size less. Here in case of sodium atom, its size more. Now similarly, when we speak about chlorine atom, its electronic configuration, that is 287. Now I am making here small figure, that is neutrons number, that is equal to 18, protons number 70, little large only require. So I will make it, this I am erasing now, this part I am erasing. Here neutrons number 18, protons number 17, first orbit 2 electrons, second orbit 8 electrons, third orbit 7 electrons. Similarly here, this is a chlorine atom. Now I am making, it's below chloride ion. Here neutrons number 18, protons number 17, first orbit has 2 electrons, second orbit has 8 electrons, third orbit has again 8 electrons as I shown you here. So in this case, here 3 orbits, here again 3 orbits, but problem is here number of electrons more. As a result of it, here occurs some repulsion force or repulsive force. Repulsive force. Here actually what is happening? 1 electron is adding. So I am showing you that way, 7 plus 1. 7 plus 1. 1 electron is added here in the third orbit. As a result of it, the newly added electron shows some repulsive force between the electrons which are present in the outermost orbit of chlorine atom. As a result of it, here now we can see that newly added, then it became a chloride ion. So the newly added electron shows some repulsive force. It cannot be able to match with them or merge with them. Some force or repulsion it is showing with the electrons which are present in this chloride ion. And one more thing is there. Here, as a result of it, its size becoming bigger. Because of this repulsive force between the newly added electron with the other electrons which are present in the outermost orbit of the chloride ion, there occurs some repulsive force. As a result of it, the size of this atom ion, the size of this ion increases. As a result of it, we can say that the attractive force between the nucleus as well as outermost orbit reduces. As a result of it, we can say that the size of chloride ion will be bigger. Or in case, we can say that in case of metallic ions, their size becomes smaller while they lose their electrons. At the same time, in case of non-metallic ion, they gain electrons. As a result of it, their size increases. So here we can say that the size of metallic ion as well as non-metallic ion in comparison, we can say that metallic ion's size will be little smaller than non-metallic ion. Now one more thing we can say that the metallic ion as well as non-metallic ion, both of them are oppositely charged ions. As a result of it, they have such a attractive force is there. As a result of such a attractive force, we can say that the melting point of ionic compound is very high. Again we can say that they are hard, as well as when it will fall down, it will break. So we can say that ionic compounds speciality, they have, I am not writing full, they are having high melting point. Second thing we can say that they are hard. Third property we can say they are brittle. Now all ionic compounds are not alike. They are having different look is there. Their crystals are not alike. Why their crystals are not alike? Because the arrangement of molecules of different ionic compounds are not in the same way. Their arrangement, they arranged their molecules arranged in a systematic way, but arrangement is in a different way. Means a different pattern of arrangement is there. Because of that, the crystals of different ionic compounds are different. Ionic compounds are water soluble ones. Its meaning what? They can dissolve in water. Now, as and when they dissolve in water, these ionic compounds dissociates its ions. That means, one example, sodium chloride. When it is in the solid form, they are tightly bounded with each other. No one can separate each and every ions. Such a condition, they are having intermolecular force of attraction. They cannot separate with each other when they are in solid form. But when they are dissolving in the water molecule is having such a speciality that water molecule is moving around. It will collect around the ions. As a result of it, their original intermolecular force of attraction disappears, vanishes. As a result of it, a new force of attraction is forming between ions as well as water. Because of that, we can say that these ions move inside the water. They move inside the water. Ionic compound means sodium chloride. In that, many molecules of sodium ions, sodium chloride will be there. These sodium chloride, now if we are taking a crystal or we are taking one spoon of sodium chloride and putting inside. So in that, this is now sodium chloride only, one molecule I shown. But if you are taking one spoon of sodium chloride or salt, in that many sodium chloride molecules will be there. Now, each molecule is formed by joining sodium ion as well as chloride ion. When it is dissolved in the water, when it add in the water, we have to stir it well. So we have to supply energy. That energy helps for dissolving sodium chloride inside the water. But when sodium chloride we are adding as well as mixing, that particular time what water particles are doing, that is going and moving, or we can say that that is covering sodium ion as well as chloride ion. As a result of it, their original intermolecular force disappears. As a result of it, a new intermolecular force is forming between water as well as ions. Here two types of ions are there. One is positive ion, other one is negative ion. Between these ions, a force of attraction is producing by water as well as ions. As a result of it, we can say that in this water, now you can find that everywhere either positive, we can say that there will be positive as well as negative ions. As a result of it, we can say that there will be the formation of aqueous solution. Aqueous solution, that means a solid sodium chloride or solid ionic compound changed now. Then it became a liquid condition. We can say that aqueous solution became. A water plus sodium chloride became. So here we can say that in this case, previous condition intermolecular force was very high, but here now as a result of a new intermolecular force, their force of attraction reduces. As a result of it, ions start to move separate in the water. As a result of it, you can find that there will be the formation of aqueous solution of water as well as ionic compound, sodium chloride or any other ionic compound. One more important thing, ionic compounds cannot dissolve in kerosene as well as petrol. Why they cannot dissolve in kerosene as well as petrol? Because water is having the capacity to form a new intermolecular force between water as well as ions. This ability is not there between kerosene as well as ionic compound or petrol as well as ions which are present in the ionic compound. As a result of it, ionic compound cannot dissolve in kerosene as well as petrol. Ionic compounds cannot conduct electricity in the solid form. At the same time, when we dissolve it in the water, it can pass electricity through it. Or we can say that if you are taking a spoon of or a large quantity of ionic compound and heat it, once we will heat it, it starts to melt. Afterwards, the molten state or fused state of the ionic compound, that will be in the liquid form. Through that, electricity can flow. Now, why electricity can flow through molten state of ionic compound, or we can say that dissolved state of ionic compound? Its meaning, in dissolved form or molten form or fused state, we can say that the ions will be in motion. They may be in moving condition. They will be in the moving condition in the liquid state. We can say that they are in mobile condition. Mobile means a moving condition. They can move from one place to other. So this is in the dissolved state, I can say. So here dissociation happened. Actually sodium chloride in the solid form. In the solid form, they are tightly bounded with each other. As a result of it, they do not have any movement. But when it is dissolving in the water, their dissociation happens. What is meant by dissociation? Dissociation means a separation of ions. Here sodium chloride is there. They are tightly bounded, joined with each other with such a intermolecular force of attraction. But when it dissolves in the water, that time sodium ion separates, chloride ion separates. then that will move in the liquid. Now here we can say that this is the water as well as sodium chloride condition, dissolved condition I can say. This is in the dissolved state. Now suppose if you are taking a container, in that we are taking some quantity of sodium chloride or any ionic compound. Then if we heat it, we can say that it will melt. Then we can say that will be in which state? Molten state, or we can say as fused state. Even in molten state or fused state, we can say that ions will be in mobile condition. They will be in moving condition. So we can say that when ions will be in moving condition, their electricity flow will take place. If ions are tightly bound with each other, that is happening only in the solid state, their electric current flow won't take place. Because of that, we can say that ionic compounds are electrolytes. Ionic compounds we can call in other name, they are electrolytes. Electrolytes means they have the capacity to pass electricity. Ionic compounds having the capacity to pass electricity through them when it is dissolved in the water or when they are in the molten state. So we can say that they are electrolytes. Thank you.